Well, hey there, everybody. It's your boy, Mr. Perry, and here we are, Unit 7, Lesson 4. It's time to start talking about array list algorithms, so let's get into it. You might remember from the previous unit, Unit 6, when we talked about arrays, and we got to Lesson 4, we had this big bulleted list of array algorithms that we needed to become familiar with. So we spent some time looking at how do you determine the min or the max, how do you compute the sum, the average, everything else. And then we started doing fancier things like shifting or rotating elements to the left or the right and reversing the order of elements. So these were all of the array algorithms that we're supposed to be familiar with out of Unit 6. Well, now we're in Unit 7 and we're talking about array lists algorithms. And guess what? It's basically the exact same list of algorithms, except we now need to look at how do we adjust the syntax so that we're dealing with array lists instead of arrays. And that's what we're going to be getting into here. So the first thing we'll do is we'll look at the difference between array commands versus array list methods. And if you'd like to, feel free to pause the video right now and read through what you have over here for the array list, for the array commands, and think about how you would replicate the same thing over here with array lists using the array list methods. So feel free to pause the video and try to work that out. But I'm going to go ahead and start explaining, how it all works. So we have an array of integers called nums, and it's set to the length of 5. And then we are hard coding all of these items in there. And then down here, we're changing some of the items to be different values. So if we take declaring an array of integers called nums, what is the equivalent of that for array lists? Well, it would be an array list of integers, and I would just call it list. And there you go. I don't have to worry about, a number like 5 or whatever, because we're just using the default capacity of 10. And there we go. So now we got to look at, all right, well, how do we do this? How do we add 2, 4, 6, 8, 10 in here? So here's how we did it with arrays. We would just assign the value to each index value. But of course, with array lists, we have the method called add. So the name of our array list is list. So we just do list.add2, list.add4, and so on and so forth. Now down here, nums at position 1, or nums at index 1 is equal to 14. So it's already 4, but I want to change it to be 14. So the array list equivalent of that is the set method. So list.set at index 1, the value of 14. That's going to change this 4 to be a 14. Now what we want to do is we want to, let's see, nums at index 2 is equal to whatever is in nums at index 1. All right, so how do we go about doing this? Well, again, we're trying to reset index 2. So that means we're going to do list.set. And we're going to say at index 2, we want it to be whatever is in index 1. Well, in that case, we can do the list.getOne method. So this will return whatever is at position 1, which in this case, of course, is 14. And it's going to set index 2 to be 14 now. So that would change the 6 to be a 14. And then finally, nums at index 3 is equal to whatever is at nums at index 1 plus 1. So we're changing index 3 to be whatever's at 1, and then we're adding 1 to it. So again, we would use our list.set method. And now we're setting index 3 to be list.getIndex1 plus 1. So this is the array list equivalent of doing that same thing here. And then, of course, with arrays, we had the length instance variable. So I could assign nums at index 4 to be whatever nums.length is, which of course is 5. And we have something similar to that in array lists. So you can do list.set index 4 to be list.size. And that'll do the same thing. So, it's a lot of the same mentality. It's a lot of the same logic behind, what we're doing, how we work with array lists versus arrays. We just need to get used to the different syntax. So having said all that, let's go ahead and convert some of these array list algorithms, some of these array algorithms to be appropriate for array lists. And in order to do that, we're just going to go line by line, and we're going to look at, okay, well, for each of these lines of code, what pertains to an array, and how do we modify that to be an array list? So here we're passing in an array of integers called ARR. So I'm going to change that to an array list of integers, and I'm going to call it list. Now, the next one, it says int min index is equal to 0. Well, that doesn't need to change. That's fine. But now we have our for loop. And so when we get into our for loop, where we start looping through the rest of the array to see if something is bigger than the current, or see if there's something smaller than the current min. Well, we can't do as long as I is less than or arr.length. We have to change that to be list.size, because again, the name of our array list is list, and again, it's the size method that we're working with. So now we're going to get into here. So if array at min index is greater than array at I, so this is checking, is the current minimum greater than the current index value? So we obviously would need to change this. So we would change this to be if list.get min index is greater than list.get I. This is going to check min index is 0, and this is going to check the rest of the array using I to see if anything is smaller than the current min index. This part down here is fine. It's not pertaining to anything having to do with arrays. And this one down here is also fine. We would want to return the index of whatever the current minimum is. So there you go. Pretty straightforward. That's how you take the algorithm for finding the min of an array and transform it into something that's appropriate for array lists. And let's go ahead and do a couple more of these. So now we're going to look at shifting to the right. So this was our array algorithm for shifting to the right. And again, what this one does is it passes in an array of integers, and then it gets the whatever element is at the very end, and then it loops through in reverse, and it assigns each current element to be the element before it. And then finally down here, when you get to 0, because again, remember, this is going to loop as long as I is greater than 0. And when you get to 0, you're going to go ahead and reassign it to be the last index, or whatever was at that last index. So let's look at how we would go about transforming this. So obviously we can't have an array of integers. We need an array list of integers, and we're going to call it list. Down here, we've got int last equals, all right, so array at array.length -1. Okay, so what we need to do is change this to be list.get, and we're going to get whatever is at list.size -1. So this would be the equivalent of doing this one right here. All right, so instead of array at array.length -1, we do list.get, and we're going to get a list, the size -1 will get us that last element. Now we need to look at our for loop, and so this one says for int I equals array.length -1. So we're going to start in that last index value. Obviously, we need to change that to list.size -1. Everything else looks good in our for loop header. Now, array at I is equal to array at I -1. So we need to reset whatever's in the current index to be what's in the index behind it. So we're going to do list.set at index I, and what are we going to replace it with? We're going to replace it with list.get I -1. So this will do the same thing as what we saw before. And then finally down here, array at 0 needs to be whatever is last, whatever we stored up here. And so again, we're going to do list.set at index 0, whatever was at last. Again, whatever we had stored up here. And there you go. This is our updated algorithm to represent array lists. We've just got one more to do here, which is reversing elements in an array. Feel free to pause the video and try this one on your own before following through on the video. But if not, we're going to go ahead and just make our way through it. So again, line by line, here we go. Public static void reverse int array. Obviously, we're not going to be sending in an integer array. We're going to send an array list of integers called list. And then the next line is just getting the setting our starting index to be 0. So that one's fine. And then our end index is array.length -1. Well, obviously, we're going to change that to be list.size -1. And then it says while start is less than end, well, there's nothing really to do there. That has nothing to do with our array, so we can leave that as is. But it says int temp is equal to array at start. All right, so we're going to have to do something here. We're going to change this to list.get start. And now we need to reassign array at index start to be whatever's in array at index end. So that means we need to set list.set at index start, whatever it is at, and we're going to go ahead and do list.get end. I realize I'm missing another parenthesis here, but we're going to go ahead and just ignore that syntax error for now. There should be another parenthesis here to close that one right here, but no big deal. You get the idea. Finally, array at end needs to equal temp. So we're just going to do, again, we have to figure out how do we reset this index value. Well, that's going to be list.set at index end, whatever is in temp. And start plus plus and end minus minus, those are fine as is. So here you go. This is the updated version of the reverse method, this time representing array lists instead of arrays. All right, guys. Well, there are others to work with, but you know, again, this lesson isn't too bad. It's just a matter of looking at what were your algorithms for arrays and how do you go about transforming each of those algorithms to represent array list syntax. I'll see you in class. Thanks for watching. And as always, be sure to leave a question or a comment.